My name is Djura. I'm Associate Professor of Structural Engineering at IUSS Pavia in Italy, or better known as the Rose School. So today we're going to look at the structural module on the Djura online platform, and specifically the EDP-DV generator that has been developed here. So the EDP-DV generator automates the connection between the engineering demand parameters and decision variables, which are generally loss metrics, and we use these in risk assessment. So when we talk about the context of building loss assessment, we're looking at essentially story loss functions because we're essentially relating the story demands as EDPs to the economic losses as DVs. So this application generates simplified functions to estimate the economic losses for a given level of structural demand, basically. So it means that we no longer have to have a detailed component information required by procedures described in FEMA P58 and tools like PACT. We can simplify this whole process by just using a couple of story loss functions generated with a tool like this. Also, when we're looking at the regional assessment of many buildings, this approach can really help the accuracy of the loss estimates, since analysts no longer need to rely on the simplified damage state loss ratios, which can be a bit subjective at times. So here we're going to talk about loss, but this kind of approach can be extended to other issues like functional recovery, environmental impacts, and things like that, which are also showing on the screen right here. So we're going to go ahead and click into the economic loss side of things. So when you click in here, you see one of the first things you need to do is you need to upload your damageable inventory, right? So this is essentially a definition of stuff like quantities, fragilities, consequence functions of the different non-structural and structural elements within the building. So this is like an initial definition of what we think is in the building, which will help us develop our story loss functions, okay? So you can go ahead and upload this as a JSON file on the right hand side if you have this information already compiled, or we can implement it and create it on the inventory page, which we'll show in just a second, okay? So in the case of the JSON file, we can see an example right here in this little GIF that's been created, so we can see the different components and the different information associated with them. But if you don't have one of these, you can download an example by just clicking on this button right here, and it will show you this information on your local machine, and you can create something similar if you want and just directly upload it here. Otherwise, you can go ahead and create one on the next page, which we'll see in just a second. Also, we have some information about the correlations, which we'll see a little bit later on. And also you can download a sample file here, which you can also upload a little bit later in the process. So overall, this is a handy tool that makes risk assessment easy by providing comprehensive analysis from just a single interface, right? Because we're just dealing with these engineering demand parameter to decision variable functions, okay? So we're not dealing with these huge inventories that we're inputting right now. We're going to synthesize and simplify them in terms of these functions that we're going to develop. So we've included several examples of papers and studies in the blog post about this, and you can see this on the website as well. So let's move ahead. Let's say we want to create our own inventory. We don't have one right now. We want to create one from scratch. We can go right here and we can look at the left-hand side and click on inventory. So you will see when you get to the platform, one of the first things you see is there's already an inventory has been pre-compiled, right? So this is to help you get started. Basically, we can just go ahead and run this, and it will create a set of functions that we can use in our analysis. But of course, you can go and you can add new components. You can delete them as well, as much as you want. So one of the first things we can see here on the top is we have this download button. So we can go ahead and download the inventory as a JSON file. So like we had on the previous page. So we could download this whole inventory right here, maybe modify this on our local machine in a more scripted way and re-upload it again if we wanted to. And also we can add a new component here by clicking on this button, and we'll see an example of that in a second. We have these actions here for the different items that have been uploaded, so we can modify the ones we want, we can delete them, and so on and so forth. So just looking at the items that have been uploaded already, so we can see the different names. So we have lights, we've got water distribution piping system, switchboards, stairs, doors, windows, things like that, okay? So you'll see examples of where this information came from on the blog post. This came from a previous study that we've worked on, and maybe where some of the data has come from here. The second thing we can notice is the EDP that these are sensitive to. Okay, so we have different basically structural and non-structural elements and also building contents. And these are going to be sensitive to different engineering demand parameters. Okay, so we can see in the case of the lights, we're sensitive to the peak floor acceleration, but also in the case of the exterior beam column joints, we're sensitive to the peak story drift, for example. And also the component type, we can group these as the non-structural elements or structural elements. This is just like a classifying system that you can define pretty quickly. Also in the case of the groups, so we maybe want to group these together. We maybe want to have the story drift structural elements. We're going to group these all as group number 1. And then in the case of the story drift sensitive non-structural elements, we're going to group these together as group number 2. And in the case of the floor acceleration sensitive non-structural elements, we're going to group these together as group number 3. We can create as many groups as we like, but this is just a general system that will give us essentially 3 different story loss functions that we can let's say break down our losses in terms of. Okay, so if you want to have a further refinement, you can go ahead and do that as well. But this will be clearer later on when we see the results. So one of the first things we can do is we can go ahead and add a new component. Okay, so what are we going to do? We're going to add a whole new component. We're going to call this the heating distribution system. Okay, so we're going to type this right in here. So we're going to have heating distribution system. And also from my notes here, I can see that we're going to have a quantity. We're going to have 1.904 of these. So this is the quantity. It depends on how it's defined. If it's per meter, if it's per meter squared, if it's a unit, let's say there's a certain many of them, there's going to be 1, 2, 3 of them, and so on and so forth. Okay. So what engineering demand parameters is going to be sensitive to, we can have it in terms of peak flow acceleration. The component type, we're going to classify it as one of these. We're going to classify it here as building as the non-structural elements. We could also maybe in a different study, we maybe want to further break this down in terms of non-structural and also building contents. But here we're just going to call it non-structural elements. And we're going to group this as the group number 3 like we had before. Okay. Now we're going to add the damage state information. So the first damage state here, we're going to have, it's going to have a median demand. So this is basically the component fragility functions. So we're going to enter these here. So we can see we have a median demand of 0.55 G of PFA and also a dispersion of 0.4. The repair cost we're expecting with this is going to be 307.38. The cost dispersion, we're going to assume it to be something like 0.1. And we're going to say that that's a normally distributed. Okay, so what this does in the simulations is going to sample for each single Monte Carlo simulation, which we'll do later on, and you can read about in the blog post and the associated papers. It's going to sample a repair cost from something that has a mean value here, a dispersion of 0.1. It's going to be normally distributed. Okay, so it takes into account the fact that the cost is not always going to be a fixed value. So that's the first damage state. We're going to add a second one. And for this one, we're going to have something like 1.1 G as the median demand, 0.4 once again. This time we're going to have 2.32, and also 0.1. Okay, and that's basically it. So we're going to save that in there, and we can see that our heating distribution system has popped up here as well. So at the same time, we also may want to delete some components. Maybe we don't want to consider these at all in the loss assessment, and we want to maybe move or modify something. So in this case, let's just look at the chairs component here. Let's say we want to delete this. We can just come over here, click on that little bin. Say you want to, are you sure you want to delete this? Yes, we're absolutely sure. And that's it, gone. And lastly, we may want to edit some of the components. So in this example, we're going to look at the exterior beam column joints by increasing the quantity from, we're going to look at this one right here. We're going to come over here. And we're going to click on modify. So what are we going to do? We're going to increase the quantity up to 30 of these. For some reason, we want to increase that. And at the same time, we want to change some of the damage states. Okay, so in this case, we're going to have 0.02. We're going to increase that to 0.25. We're going to leave the dispersions exactly as they are. We're going to leave the costs. No, we're going to change the last cost here. We're going to change that to 3300. We're going to leave the cost dispersions as they are, and we're going to leave all of this as we are. We'll just click on save here, and we've successfully modified the properties of this component in the damage level inventory. So like I mentioned before, if you're happy with this, you can just go ahead and download this. So this is something you could save to your local machine, but we're not going to do it right now. We don't need it locally, but you could do all of these operations locally and open this on your local machine as a script and just modify the numbers directly. It'll be in a JSON format, and it should be relatively self-explanatory, the structure of the data. So once we're happy with this, we can go ahead and we can look at the advanced options here. Okay, so we can click onto the next page. And one of the first examples we have here is we're going to look at the component correlations. Okay, so this is basically taking into account for the fact that when we have the loss of one component, this may be indirectly or directly, basically, impacting the loss associated with the different components. So for example, there's a few examples written on the screen right here, but if you think about it logically, right, we may have a specific non-structural element that didn't need any, doesn't require any repairs during for a certain level of EDP. But because there's an underlying structural component or something else associated with it, we may actually have to damage or temporarily remove this non-structural element to gain access to the other one. So let's say there's a dependence of one component on another one. So this kind of interaction and realistic dependence of the different elements can be accounted for here. Okay, and we can do this here with this component matrix. So we can see with the different components we've already defined on the previous page. We can look at the different dependencies right here. So I think right now we have no dependencies. Everything is independent. Yeah, we can see it right here. So we could go ahead and run this analysis as it is, and it wouldn't take into account any of supposed dependence that we have between any of these. But we're going to define one here just to show how it works. So what we're going to look for here is the dependence of the switchboards on the water distribution piping system. Okay, so we come down here to the name of the component we're looking at. So we're interested in the switchboards. Okay, currently it's listed as independent. Where we're going to say that it's now dependent on what happens to the water distribution system. Okay. And what we're going to say here is that the damage state 1 of the switchboards, okay, so that damage state is currently not dependent on anything. But what we're going to say here is we're going to say it's going to be dependent on damage state 2 of the water distribution system. So that when the water distribution system enters into damage state 2, the switchboard is now going to be in its damage state 1, basically. And when we're finished with this, we can come up here and we can click on the save matrix. We could also upload this as well. We could also upload the correlation matrix like we had before, but of course we're just going to implement this directly here on this page. Another thing we can look at here, instead of the component correlations, we can actually go to the advanced inputs. Okay, so these are like settings and just things you can have a look at while you're generating your story loss functions. Okay, so you can see one of the first things we're looking at is the number of Monte Carlo realizations we want to look at. Here we're looking at a simple example of 20, for example. We can increase this to many more, so we can say something like 50 if we want. Also, which kind of regression is going to be used. We can also use different functions. We can have the viable function like it's described down here. This is the functional form of it, so it's going to be the decision variable we're interested in. So loss right here is going to be a function of the EDP with this functional form here. So we're essentially going to be fitting the coefficients alpha, beta, and gamma. At the same time as well, we can use this functional form that was described in Papadopoulos 2019. Similar idea here. We have just a couple of more coefficients, and the function will be fitted there as well. In this case, we're just going to look at the viable function. Okay, the normalizing DV value. So this is just the way that the graphs are presented if they're going to be normalized anyway. And in this case, we're just going to leave that as 1. In the case of the peak story drift, the maximum value, these are just axis limits, so the plotting doesn't look kind of funny. So we're going to set the maximum peak story drift. We're going to analyze it all the way to 10%. The same thing with the peak flow acceleration. We're going to look at all the way up to 5G. Okay, we can also include and exclude correlations. So because we've included some correlations, we're going to click on that button and we're going to save the changes here as well. So once we're ready, we can go right ahead to the visualization. Okay, there's nothing on the screen right yet because we have to go ahead and run our analysis. So we can run this and we'll see the results will pop up on the screen in just a couple of seconds. Okay, so this is the result basically. So this is the engineering demand parameter. So in this case, we have the peak story drift and we have the decision variable, which is the economic loss in this case. Okay, and what we can see here is the general trend. So that is something like 2% drift. We can go in here and we can query all of this data. We can turn off that data for a second. We can say that about 2% drift, we tend to have a value, the fitted value of 295, so 295,000, I think was euros or whatever the monetary value we had on the previous slide. We can see how this gradually tails off. So any level of damage or EDP, so structural demand, we can estimate the economic loss basically from something like this. So you can look at the tabulated value here as well. You can see all the data is tabulated right there. We can close this. We can come in here and inspect all of these things. Turn the data back on. So this is the simulations we had from Monte Carlo simulation. We can turn off the fit. We can see the overall trend. So this is the average trend we have from all of that data we had. And we can turn off maybe all of these, and we can see the simplified function that we'll probably use in our analysis. Because we used a viable function, this is essentially what is being plotted here. We can also see the fitting coefficients are displayed on the screen, right? So we can see the alpha, beta, and the gamma values right here. So just going back, we can turn back all the data. We can also see a summary of what we did here as well. So we had 50 different realizations with the viable function. We're looking at peak story drift, and these are just some error values between the fitted function and also the overall trend that we observe. So we can see that the overall error is quite low. So this is for the first group that we defined in our inventory. So we can go ahead and we can look at different ones as well. So this is looking at the structural components that are sensitive to peak story drift. We can also look at the non-structural components which are sensitive to peak story drift, and we can see that the functional form looks quite similar, but it changes, the overall values change because this is a different group that we're looking at. So this would be a second story loss function we're looking at, and again this is a function of the peak story drift in percent and also the decision variable. We can go ahead and look at something like this for the peak flow acceleration. Again, this changes on the horizontal axis, and decision variable here, and we can see the different trends in the data. It looks a bit different because of the diversity of the components we're looking at, but this is the overall trend we have here. Okay, so we could look at we can zoom into different parts of it. We can zoom in and see what was actually happening if we're interested. We can reset that out, look at the tabulated data like we had before, restore this back to the way it was, so the initial setting. And also we can download this as a figure. Okay, so we can download that as a figure on our local machine if we want to use this in a paper or a report. Again, this is showing us an example of the different errors between the different components. Okay, so this is just showing us what we had, and it's showing us the different values that we have right here. So the last thing we can say is that we can download all of this. So we can download all of these functions. We can download all of the data. We'll get all this stuff we have right here, and it will be downloaded to our local machine, and we can go ahead and use this in our loss assessments. So here we're just looking at a fast engineering demand parameter and decision variable generation tool. So the EDP-DV generator, basically. So we've tested this and we're adding more features and flexibility. So please let us know if you've got some specific needs. We plan to further improve the regression functions as well as add more flexibility for the consideration of things like functional recovery, including that more directly, and also the idea of environmental impacts. These are some things we're working on, and we can implement these pretty quickly. So let us know if that's something you're interested in. We can chat with you about it. So this video summarizes how to use the user interface as well, but we can also use this with the, so if you're using something like Python or MATLAB, you can also call this directly as an API. So if you've got your code set up and the JSON files organized in your machine, you can do this generation automatically, basically querying via API, and it will return the values to you without using this user interface. This is handy for setting things up and seeing how the thing works, but if you want to do this on a more repeated and systematic basis, maybe a more code-based approach could be more suitable and save you a lot of time, basically. So this is just one of the applications we offer. So get in touch if you want to see the service, visit the website, drop us an email, and stay tuned as well for different videos, and contact us if you have any questions or would like more information. Thanks.